What is up, guys? It's the Kilograms. We are back with another episode of Over Engineering Live. It looks like it didn't change. Let me go to my dashboard again to change that. I must not have clicked save. Alright. Over dash engineering live. And it's art, because sure. Update information. Okay, now our stream should be good. So today, hopefully I can, no, okay. So we're designing today it's an attachment for, on my air conditioning. So I have one of those like rolling air conditioner things. And basically my idea is, so this is the Bangladeshi Eco Cooler. Now, there's a debate whether the thermodynamics of it actually works. So, lowering pressure to drag in ambient air. So, it's pulling in air. That's kind of just part of how the setup of the houses are. So, they're tin huts. They have two windows for the cross current. So, it's pulling outside air in. So, it's moving the air faster when it comes through. That's the important part for what I'm designing here. So it's it's pulling the air in from this larger surface area. So with Bernoulli's principle, you have to think about the surface area moving through that, and basically I'm trying to replicate that large surface area here to small surface area out, so that the in speed is directly relative, actually, and I think the Joule-Thomson effect explains that, but I'll go into that in a minute. So I don't have the actual equation anymore, and I'm not very good at math, but I'm good at Googling to figure out what I need to know about a situation. So basically the surface area of this and the surface area of this are directly proportional to the speed of the air going through it. Great. Now I have my my baseline. So in my case, the one side, it's actually square, and it's about so after I calculated the surface area of both sides, the one side is 10 times the size of this, so the speed of the air coming out will be going 10 times faster. So that kind of bypasses if the Eco Cooler works or not. That actually doesn't matter for what I'm doing, because what I'm doing is I'm not necessarily so I believe when pressure goes up, man, I'd have to look that up. But basically, I'm not trying to mess with the temperature of the air necessarily. That is part of it. But in this read through of this, it seems as if, actually, no, this is not a Mac. I can't make it bigger, easier. So when it's kind of like the blowing cold air and blowing hot air, type thing. But the real thing that actually happens, it seems, is the Joule-Thomson effect here, which gas or liquid forced through a valve, so that no heat is exchanged with the environment. Can't really guarantee that. But what we're doing there is the throttling process here. So we're bringing that air, we're making it move faster through the thing when we're also, we're forcing it through a valve. So basically what happens here, room temperature, blah, 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 coolant expansion. Right. So on expansion, when they're throttled through, they experience the same effect, but at lower temperature. Oh, these other gases are different. Okay. So with this Joule-Thomson, basically what we're going to do is we're going to feed in already cold air coming from the AC. We're going to not necessarily compress it. Not necessarily. Because it's not like a pressure vessel, so I don't think we can count that. But the speed will be increased by 10 times. And also this Joule-Thomson effect, it's coming through that orifice. And when it expands coming out of that, that's what cools. So it's potentially colder air. I'll have to recheck on that one. But when it comes out, it's gonna expand and then absorb the heat, if I'm understanding thermodynamics correctly. So that's all that we're gonna do for this episode. I just needed to cover all of that because that's the whole basis of this entire design here. So I want the side, not that it matters once you click it. Okay, I think we're okay with that. So I have some, yeah, so the area in versus the area out, it was 200 by 100, I believe. Oh, 200 by 165, so that's like 32,000. And then the exit just happened to be, because I made it, a nice round number, 20 by 165. Well, let's design that so I'm not just gesturing wildly in the air. Yep, we need a line here. So I need... Hi, Mittens. Mittens Cam, coming soon. We need 40. Who would have thought that the 2 years of engineering CAD stuff would have actually prepared me for something? Designing my own AC. Okay, so this one was just a nice round number of 40 that we wanted there. So then enter, right? Okay, so then we want, okay, I'll do that easier next time. So we want 203. So the fun part about designing live is that you have to do it ahead of time too. So I actually designed this. I just did it 160 because let's make it. Am I doing these lines? Not great. Okay. Let's do 170. Cool. Right, Mittens. Okay, and then we wanted 20 to be the exit. So I'm thinking that we should have, let's do 35, and then we can offset by, oh, that math isn't fun. Let's, can we just undo both of those? Uh-oh. Can we shift control? We can't redo. Okay, so I'll do the line again. Don't worry, I'll get better at this. So we wanted 170. Yep, and then we wanted. You know what? Let's do 30. So I can have 5 millimeters on each side. I still haven't really decided if I want my exits to be like circles drilled in the top, or if I want them to be just an opening, like a square opening. And I might even put threads on it to try and put other adapters to blow in different directions. I don't know. So this is over engineering. We're going to do it crazy to do it crazy. Okay, so I think we're good here with this 40. We need to do a spline, right? That sounds right. Yeah. We'll go here, and we'll go here. Oh, no, I wanted the other. All right. Oh, we still got it. So let's go like halfway, right? And then, oh, no, that's not halfway. We'll get there, don't worry. Okay, so do we want an arc? Ooh. Tangent arc, right? Center point arc. Yeah, select 2 points. 1, 2, and then we want it the opposite direction. How do we get it on the other direction? I don't like that either. Okay. Okay. Start point, end point. Okay, that's what we wanted. So I wanted to kind of come out smooth here. That looks pretty good. Cool, cool. So this is like from the side here. So we're looking at it. Well, we'll extrude it real quick in a second here. I just want to make sure. So what I really would like to do is also to make veins on the inside so that the flow that comes out is sort of laminar, so that it reaches farther into the room and that it doesn't. So maybe I'll just put like a grid up top here or like a grid of holes. I'm not really sure what would distribute it the best, so I might look that up at some point, like figure out what the best shape for getting air into a like rocket nozzles. I don't know, because we're over engineering this. This is not necessary. I could just leave my air conditioner as is, but this will make it 10 times faster and potentially cool way better, with all the math explained earlier. Let's see here. So what I want to do next, I don't think I need to put any fillets or chamfers on there. Let's and it's, you can say it either way, chamfers or chamfers. People might say things, but okay. So actually, I think we're good to. Yep, I'm good with that one. Let's just extrude it because I think we're right. Boop, boop, boop. Sure. Oh. Okay. That's... What am I doing here? Let's just extrude. Beautiful. How big was it? I think it was 160... 165. There it is. Beautiful. What was that thing that I just did? No, 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 no. I need redo. Get out of here. Okay. Oh, I think doing, yeah, if you right click, it does this weird stuff. Oh, it must have done that. Hole. I don't think I wanted a hole. Maybe I did want a hole. Nope. Here, let's grab this top here. Take a look at that. Nope. Stop. Oh, no. Actually, that's exactly what I needed. What I do? Sketch. Oh. Okay. Repeat line. Press, pull, redo, hole. I gotta remember these things. Okay. I want to exit it right now, though. So we're in that sketch. What do I want to do here? How can I do like a grid easily? Maybe I just do... Ooh, I should offset. I think that was one of the... No, it wasn't. Might have been O. There's no offset here? Okay. Was it O? O is offset. Let's offset... We said 5 millimeters from each side, right? And I wanted it on this side of the... No, why are you on the other side? Actually, I did want the undo at that point. So let's do O for offset. Can I? 5. Okay. Wait, is that on the other side again? How did it? Oh, it must be -5. Okay, all right. See, we're learning this together. This is probably the best way for anyone to learn this because I'm making the mistakes, so you don't have to. So let's go O again. We're learning all these shortcuts like right now. And this one, it'll actually be 5 millimeters. No. What? How? Offset. You crazy. What? I'm so lost. Maybe offset is some weird, like, other dimensional. You just have to think of it differently than you'd expect. Okay, so offset's a 5 there. Actually, we might be able to do a pretty good, a pretty decent grid. But I gotta kind of think about, well, let's offset these by 5 again. Or -5, depending on what part of the map you want to be on. What does 5 do here? No, we want -5. guess. Maybe offset like to the interior is a thing. I'm not really. Okay. Oh, and then we go. Let's test this out. So if we do negative, it should be towards the interior of the -5. Okay. Look at that. Learning some stuff. So then this section will be our cutout. That should work okay. I might actually be able to. So there's a thing called loft. So it's a transitional shape. I'm thinking maybe I could use that. Otherwise, I think pipe might. No, I think pipe actually just makes a pipe. I don't think it makes it out of here. So the whole. What was the other thing that was? I think there's a modify. Offset. Shell. Yeah, so shell was another option we have here. I don't think we need. Well, you know what? Let's okay. We're going to switch to the bottom and offset the sides here towards the middle. So we have those guidelines from this side. So if we want to connect those actual like curves and lines, we can. We don't necessarily have to, because I could just say, you know, make a shell of 5. But I think this is better just overall. So let's do. What am I doing here? Did I not select one? There. Let's get this out of there. So we want to offset that. What? Oh, I think I need a new sketch. I think that was So I'm not sure why the offset's not cooperating here. Did I have to make this a new sketch first? And then we can. Weird. Bodies, sketches, what do we got? Repeat, create, sketch, no. So that's a face. What is this like an extended line from that? Or is that just showing there's a line behind? Interesting. You know what? I am going to give shell a try and see what happens. Let's do. It was 165 tall, so let's do or it was 170 tall, right? Oh, that's the offset. Okay, let's do 5 millimeters. Okay, direction inside. Both. Can I move this around a little? Okay, so it's not connecting that, but I think that's fine because our holes line up anyway. So we can just. This is actually turning out okay. Real quick here. Real quick, like. Okay. So let's just say okay. And then, oops. See. I'm used to, what is it called? Tinkercad, which, like you right click to move, or Cura, you right click to move stuff. So here, I think all we gotta do is just make a hole, distance, hole type. Oh. See, this is where we kinda, Oh boy. So I don't want a hole. I want maybe this. I want a shell. Modify shell. Direction inside. Oh, there. 5 from the outside, like our markers. Really. Inside thickness 5. One. Oh, no, don't do that. Don't do that. Oh, wait a second. Let's see what that... Oh, that's putting it around the edges. Let's not do that. Can I just extrude this? Just extrude it inside? Right? Zoop. Oh, don't do this thing. I keep trying to like move it to look at it better. Direction one side, extent, distance, operation cut. Cool. I think we may have our... Wait, what? Is it a one-sided hole? Or is it just gray on the other side of the... Here, let's show the grid. Is it see-through? I can't tell. Yeah, it's see-through. Okay. I was concerned there because it was gray on the other side. Okay, so I think this is kind of what I wanted to accomplish today. Not too long an episode, but you know, you kind of got the whole over-engineering part. I'm gonna work on like offsetting some grids in here. Maybe I'll like offset these, make some lines, and then extrude the lines to match the... I'll have to look into that because I might have to use this as the cut somehow. So I'll have to look that up, but you know, make sure to like and subscribe. Check out thekilograms.com for all sorts of other stuff. I'm doing lots of things now. And I will catch you guys next time. Peace.